For decades, we've been told something very simple. If you want to lose weight, eat less. If you want more energy, push harder. If your metabolism slows down, it must be your fault. You didn't try enough. You didn't diet hard enough. You didn't burn enough calories. But what if that belief is the mistake? What if the real reason your metabolism feels slower has nothing to do with calories at all? What if the real issue exists at a level most people never think about? Inside your cells, metabolism is not just about food. It is about energy production. And energy production happens somewhere very specific, inside microscopic structures called mitochondria. Mitochondria are not just power plants, they are regulators. They determine how efficiently oxygen and nutrients are converted into usable cellular energy. That energy is called ATP. ATP powers everything: your heartbeat, your muscles, your thoughts, your hormone signals, your immune responses, your recovery. Without ATP, nothing functions properly. When mitochondria work efficiently, metabolism feels smooth, energy feels stable, recovery feels natural, fat burning works. But when mitochondria decline, everything shifts. After the age of 35 or 40, many people notice something subtle. Energy dips, workouts feel heavier, belly fat becomes stubborn, brain fog appears, sleep feels less restorative, afternoon crashes become normal. The common explanation: aging. But aging is not a switch. It is a gradual cellular shift, and one of the most significant changes is mitochondrial decline. Chronic stress damages mitochondria. Poor sleep damages mitochondria. Ultra-processed food increases oxidative stress. Sedentary behavior reduces mitochondrial density. Environmental toxins increase inflammation. Over time, cells produce less energy. ATP production drops, and when ATP drops, the body adapts. It conserves energy. It lowers output. It slows metabolic processes. This feels like a slow metabolism, but it is not laziness. It is survival adaptation. When energy production decreases, hunger signals increase, cravings intensify, cortisol rises, insulin sensitivity shifts, the body becomes metabolically defensive. Now dieting becomes harder. You cut calories, you increase cardio, you push harder. But if mitochondria are already struggling, less fuel plus inefficient conversion equals even lower energy. The body slows further. This is the metabolic adaptation trap. Low energy leads to defensive biology. Defensive biology reduces metabolic rate. Reduced metabolic rate leads to frustration. Frustration leads to more restriction. And this cycle continues. The real issue was never just calories. It was cellular energy efficiency. Healthy mitochondria are flexible. They burn carbohydrates efficiently. They oxidize fat effectively. They switch between fuel sources based on demand. Damaged mitochondria lose that flexibility. They produce less ATP. They generate more oxidative stress. They signal fatigue to the brain. Supporting metabolism means supporting mitochondria. Oxygen, movement, deep sleep, micronutrients, reduced chronic inflammation, metabolic flexibility. When cellular energy improves, something powerful happens. Hunger stabilizes, energy steadies, movement feels natural again, hormones regulate more efficiently. The system works with you instead of against you. Modern life is not optimized for mitochondrial health. Artificial light at night, chronic stress, ultra-processed food, constant stimulation, reduced sleep, long sedentary hours. All of this increases metabolic strain. The mistake was focusing only on calories. The mistake was ignoring the cell. Metabolism is not math. It is biology. It is transformation. It is cellular energy conversion. And that conversion happens inside mitochondria. If you want to understand how modern life affects your metabolism, how your cells respond to stress, and how to think about health at a deeper biological level, subscribe to this channel. We explore the science behind the system so you can make informed decisions based on biology, not blame, because real metabolic change starts inside the cell.